Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civi, and today we're going to discuss linear averaging and center averaging flow sensors in VAV boxes. VAV boxes basically have one of two types of sensors in their inlet, a linear averaging sensor or a center averaging sensor. Let's start with the linear averaging sensor. At its most basic, the linear averaging sensor is in fact linear. It usually looks something like this. Let's draw the inlet to a VAV box. Now you've got a sensor here, and it's basically a pitot tube, remember, so it's a open tube with holes in it. The top one would have holes right here, and the bottom one would have holes on the back side that you can't see in the drawing. So if you're looking into this flow sensor, and the airflow is going in the direction you're looking, the top one would be measuring total pressure, and the bottom one would be measuring static pressure. And then both of these are connected back to a controller. And if you remember, total pressure is static pressure plus velocity pressure, so the controller can use this information from the flow sensor to calculate velocity pressure, and therefore velocity, and therefore CFM. The flow sensor in this picture is kind of exaggerated. It would not be nearly as wide as it looks here, but you get the idea. Linear averaging flow sensors take the readings out here on the side of the flow sensor. The problem with that is if you have bad inlet conditions and the air kind of piles up to one side of your inlet, say over here on the left in this little green area, the holes on this side of the sensor are going to have a higher reading than the holes on the right side of the sensor. And that can skew the readings coming out of your sensor and make your controller think there's more air in the inlet than there actually is. Okay, so let's move this up a little bit out of the way. One thing to note is that linear averaging sensors don't have to be linear in shape. Many linear averaging sensors are round or diamond shaped. They look kind of like this. Let's draw the inlet. This one has a round sensor in it. Another inlet, this one has a diamond shaped sensor in it. But you can see that the sensor readings are taken over here on one side, so they are linear averaging. So if the airflow comes down the side of the inlet, just like above, the holes on that side are going to read higher, and it'll again skew the information coming out of your sensor. So let's scoot this up and make more room again so we can talk about center averaging flow sensors. Center averaging flow sensors take the readings in the center of the sensor. So let's draw another inlet here. Center averaging flow sensors are always cross-shaped. Let's clean this up a little in the center. Okay, so we are again looking into the inlet in the direction of airflow. You'd have holes here on the front that are measuring total pressure. There would be holes on the back measuring static pressure, but you can't see them in this drawing. Your pressure taps would come off here. Let's say the top one is reading total pressure and the bottom one is reading static pressure. Your reading is being taken at the center of the device, hence the name center averaging. Now if there are poor inlet conditions and the air piles up on the left side of the inlet like it did in the last one in this green area, the readings from the hole on the left, which is reading high, and the hole on the right, which is reading low, are going to be averaged in the center of the flow sensor and give a more accurate signal to the controller. This means that VAV boxes with center averaging flow sensors, like the Titus Aerocross, are not affected by poor inlet conditions as much as linear averaging sensors are. Because of this, you need less straight duct into the box inlet, about 1.5 duct diameters for our flow sensor, compared to about 3 duct diameters for a linear averaging type sensor. So that's the difference between center averaging and linear averaging flow sensors. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.